Hello, welcome back to our Science Interactive Notebook. Today we're continuing to look at energy and specifically the transfer of energy. So the things you're going to need are, of course, your Science Interactive Notebook. The page, you'll see this page in your packet. It says Introduction to Energy Transfer, and we actually want to use the one under it that looks like this. You'll see the electrical cord goes to a computer. You'll see a sun goes to a solar panel. So you want that. This one you can put to the side. It does have a diagram of what we're going to make, so you could use that as a reference. You're also going to need scissors, pen or pencil, glue, and some colors. I'm using colored pencils. You can use crayons, markers, whatever you'd like to use. Okay, so what we're going to do first is we're going to open up our Science Interactive Notebook to the first blank page after the last one we did. So last time, if you remember, we worked on speed and energy relationships. So I'm going to flip the page. That was page 13. So I'm going to flip it to page 14 right there. Alright, so up top here, I'm going to title this page first, Energy Transfer. And if you recall, when we've talked about energy transfer before, let me zoom in so you guys can read that a little bit better. Energy transfer, of course, is when energy goes from one state to another state, or from one thing to another thing. So we've looked at this on how, when we talked about speed and energy, how energy can go from potential energy to kinetic energy. That's the energy of something that is not moving to then be moved, and how energy changes from not moving to a moving object. We've also talked how energy can, because of friction, can become heat. That's another type of energy transfer, where kinetic energy becomes thermal energy with the addition of friction. Again, friction, you can see that when you rub your hands together. This is a kinetic energy of your hands, right? By rubbing them together, you're creating friction, and you can feel your palms warm up, and that is thermal energy, that warming of your hands. All right. So energy transfer up there, and then on the bottom here I'm going to write, we did page 13 last time, so this will be page 14. Alright. Today specifically though, we're going to look at two different types of energy transfer, and how this operates in the real world. And so we're going to cut this out. And actually, if you see this dotted line is where I'm going to cut. Okay? So I'm not going to cut, it's going to be one big piece when I'm all done cutting it. Okay? So I'm going to cut along the outside rectangle that is the dotted line. Okay? So we all know that we've learned about solar energy, right? And here we have a picture of the sun and a picture of solar cells. Those solar cells can be used to capture the energy, the light rays that come from the sun. Light rays carry with them not only energy because they are moving, they also carry that thermal energy because they are warm. That energy, that light energy, can be captured, we've talked a little bit about, by the sun, and stored as electricity. Okay? Then that electricity can be transported to houses, to businesses, to factories, to all sorts of different places to be used by us when we turn on the lights, when we run appliances. We see here when we plug in our computers, that takes energy, and so the energy that we capture from the sun can be transferred into electricity that we use every day. Alright, so now once I've cut this out, I'm going to fold these flaps in along this black line. Okay, so I'll show you again. So when it's like this, I'm going to flip it over and fold in the flap along that black line. If it's not perfect, that's fine. You can see mine's a little bit imperfect. Nothing wrong with that. And then I'm going to fold this one in along that black line. And when you do that, you'll see that these two flaps will kind of touch, right? They may even overlap. If they overlap, I might, like mine is, I might kind of try to bring that in just so that they both open and close without overlapping too much. Okay? And this is how we're going to glue it in. We're going to glue it into our book just like that. Before I glue it in though, I'm going to do a couple of things. I want to write a couple notes here, and I'm going to color it and then I'll glue it in. Okay? So the two notes I'm going to write on this will be actually the same note. I'm just going to write it twice. And again, we are talking about energy transfer. And so what we're talking about with these arrows is how energy comes, in one sense, how we can get energy from the sun and capture it in these photocells as part of the solar energy cells, right? So the transfer is going from the sun to the solar panels here, these photocells. So this is energy. Okay. Likewise, once we've captured that energy, it can be changed from electric, so it gets turned into electricity, and that electricity can be used to power, say, like things like a computer, which emit light, sound. Okay, so I'm going to write energy and energy. Now, before I glue this in, I'm going to color this, and again, you can take as much time as you want to color. So if you want to pause here so you spend extra time coloring it so it makes it look good. You do want to color it, even if you don't enjoy coloring, you should add some color, because the act of coloring, while also calming for us, which is always a good thing, but it actually helps us spend a little extra time understanding what we're doing and what we're talking about. So the very act of coloring, even though it may seem like, to some people, I understand, some people think coloring might be a waste of time or it might be boring, it actually does help us to remember and learn concepts, because it's a very meditative, calming activity. And when we're calm and when we're meditative, we actually learn better. Okay, that's why we like to take those deep breaths in the morning sometimes, or when we're feeling stressed. So I colored my sun. My sun's going to give off the light rays, right? I'm going to color this arrow red. Well, you probably want to color the sun yellow or orange like I did. You can color these arrows whatever color you want. I'm just using red because it stands out pretty well. Photocells, if you've ever seen solar panels or photocells, there are a lot of homes now that use these. They have these panels up on their house. It is getting cheaper and cheaper. It's still an expensive form of energy, but it is getting more affordable, so more houses are putting them on. And you can save money because you produce your own electricity. You don't have to pay for it. Normally we have to pay for our electricity. You can talk to your parents about that. Even if you rent instead of own a home or an apartment, a lot of times you still have to pay for the electricity you use. If you have photocells or these solar panels, you actually can produce your own, and then you end up not having to pay for it. Or even sometimes you can get paid for the electricity you produce. You can sell it back to the power grid. Now, I'm painting it black, and that was what I was going to say, is a lot of times you'll see that these solar panels are dark. They're usually black, and if you ever wear black outside on a sunny day, you probably know why. Black clothing gets hotter, right? If you wear a black shirt outside on a hot day, you'll notice that it gets pretty warm, right? Black absorbs heat, it absorbs light. So of course, if we build something designed to absorb light rays, we want it to be a dark color, and black is the best way to do that. So if they were white, for instance, they wouldn't absorb as much of that light rays or the heat. A lot of it would be reflected. But black is great, and dark colors are great at absorbing heat and light. So that's why you'll notice that those are black. All right. On the other side, I have a light plug. You may notice that it's like an electrical plug that you use to plug in a lot of appliances. It looks a little bit different than you might see. Again, you can color this whatever color you want. I'm going to choose blue just because it's a color I haven't used yet. Another reason I like to color my notes is it makes them stand out more. So when I go back to refer to them, I can remember which one is which. Right. Color this one red as well. Now this type of energy, so once you've stored your energy, right, you've collected and stored it. For instance, using these solar cells, you've collected the energy from the sun, stored it, converted it into electricity. Now I can use this electricity, right, to plug in appliances, for instance, lights and things, to power these electronics. For instance, we have a computer here, right? Or if you're using your Chromebook from school, or if you happen to have your own computer, it could be a TV, it could be a PlayStation or Xbox, right? Even things that aren't plugged directly into an outlet, but maybe say are charged, like a phone that has a battery that stores energy, still follows the same thing. You're using electricity that has been stored. Even if you use a battery, you plug a battery into a toy you might have. Maybe you have like a Nintendo DS and it has like a battery that you use, I don't know. But those batteries are stored electricity in the same way that the plug is, okay? The only difference is batteries only hold a certain amount, so you have to either recharge them or you have to get new ones, okay? But it's the same concept. Whether you plug in a device to use it and it has to stay plugged in forever, or like your Chromebooks, you plug them in to charge them, but then you can unplug it and use it for a couple of hours before it has to be recharged. But it's the same concept, right? All right, so now what I'm gonna do is, now that I have it colored, now I'm gonna glue it in, and then I have a couple more things I wanna do. I'm gonna write a few more notes in here, and I'm also gonna make a few more cuts. But before I do that, now that it's colored, I'm gonna turn it all the way over, and I have this blank side on the bottom that I'm going to use my glue to glue it onto my notebook. Okay. I'll take that and I'll glue it into my notebook there. Notice I did it nice somewhere in the middle, so I can open it up. It looks nice. Perfect. All right. As that glues in, I could push it down. I am going to make two more cuts. I'm going to cut across this line. And even though I will be cutting across this word energy and this arrow, that's fine. It's still going to be there. It's just going to be cut in half. Okay. cut across this until I reach the end there. Same thing on this side. I'm going to cut across on this dotted line till I reach the end. Boom. Now I have 4 flaps. Okay, that can be opened. Boom. Boom. Okay, but when it's closed, I have this. And I'm going to write a couple of notes in here. Not many today, but so under the sun, I'm going to write the sun gives, let me zoom in here. So again, I'm going to write these, so make sure you're writing them. If you need to catch up, make sure you pause till you get to this point, and then make sure you get these written in there, okay? So if you need to pause because I'm moving too fast, that's fine, or if you need to rewind, that is fine. So the sun gives off energy in the form of light rays. Okay? And then I have an arrow that's pointing down. Okay? So the sun gives off energy in the form of light rays. Okay? We get light rays from the sun, sun rays. Again, we don't see these directly. We see the effects of them. We can see, when we see a rainbow, that's a reflection of these light rays off of water. So through water you can sometimes see light rays once it's been refracted into different colors. We've studied that a little bit. You can feel light rays because again they have heat to them. So the hotter the day is, the more intense those rays are, the warmer it is. Again, if you wear a black shirt outside on a really hot day, you're going to feel the effects of sun rays because it warms you up. But we don't see or feel them directly. We feel their effects, and we can see their effects. But the sun is constantly giving off this energy in the form of light rays. And solar panels collect the energy and convert it. Sorry, I just noticed you can see that. Solar panels collect the energy and convert it. Remember, convert means to change it, transform it. This is where the transfer comes in. And convert it to electrical energy. So solar panels collect the energy and convert it to electrical energy. So now it's no longer light energy, light rays, thermal energy. It is now electrical energy, and then it's stored, and it can be transferred through what we call power grids or electricity grids to different houses in different schools and different businesses and things like that. Alright, so again, pause it if you need to catch up. Alright, now once we have electrical energy, so electrical energy can be stored and transmitted to different areas. This is a long word, so I'm going to So you can split up long words if you need to write it on a new line using a hyphen. I don't know if you guys have learned that yet, but if not, you're learning it now. So transmitted is one word, but I split it up using transmitted. So it's still one word, but since it wouldn't all fit on one line, I move it to the second line by splitting it up. So electrical energy can be stored and transmitted over what we call electric grids. Grids or power lines, things like that. That is a D, sorry. Pause that if you need to finish writing that. And we have one more note to take down here. That electric energy, right, can be used by devices so electric energy can be used by devices to produce lights, sounds, what else can they produce? They could produce lights, they could produce sounds, you could also produce heat, etc. Okay, remember ETC period means more, okay? But common things we use these electricities to produce lights, sounds, heat, okay? For instance, with our computer here, the electricity is being used to produce lights and sounds. Okay, it also can produce heat. That's why computers have fans in them. All right. So make sure you have that copied in. But here we have a really basic example of energy transfer and a complete sort of cycle of energy transfer. Starts as light, gets collected and stored, so that's one transfer. Collected and stored into as electricity. The electricity then is converted into other forms of energy, such as light, sounds, and heat. Okay? So, in a sense, we're taking one form of energy and we're manipulating it, transferring it into different ways to be harnessed for our own uses, right? All right. So very good. Make sure you have all those copied if you need to go back and finish that, and make sure you have it colored nicely as well. You can add other designs if you like, but that will complete our interactive notebook for today. So make sure you get this in there, and we're going to continue looking at different forms of energy and their transfers as we move forward in our work in our notebook. And I will see you guys next time. Take care.